Hello everyone, welcome back to my organic chemistry mini lecture. Today our topic will be cyanohydrin, which is a very important intermediate in organic synthesis. And we will talk about how to make it and the reactions of the cyanohydrin. And like usual, we will focus on the arrow pushing mechanism. First, let's talk about how to synthesize the cyanohydrin. The example shown here actually it's a ketone. It's actually an acetone, but it also works with aldehyde, and the arrow pushing mechanism are similar. And first step is react with a cyanide, which is a nucleophile, and then followed by workup, basically treat with acidic water, and then product will be cyanohydrin. You can see the structure is a hydroxyl group and a cyano group connected with the same carbon. This kind of structure is called a cyanohydrin. Let's look at the arrow pushing mechanism of the synthesis. First, this is the reactant, the carbonyl compound. Again, I said this could be aldehyde, but the example here is ketone. And this nucleophile, the cyanide, will attack this carbon, which is electrophilic, because the oxygen is more electronegative. So this carbon is partially positive charge. So the nucleophile always attack this carbon of the carbonyl and break the pi bond between carbon and oxygen. And then that step is called addition, or you can say nucleophilic addition, and form this tetrahedral intermediate. Now you may notice the negative charge on the oxygen. This is the oxide, and the second step is the workup. So just provide a proton for this oxide to protonate it. Okay, you have acid. The oxide take this proton. Okay, that protonation actually form the neutral product, and this will be the hydroxyl group. And the product here is the cyanohydrin. Okay, this is synthesized, okay, the cyanohydrin. And then the cyanohydrin can decompose if you treat with the base, for example, hydroxide. The basic condition actually can convert this cyanohydrin back to one of the reactant, that is the carbonyl compound. So again, if this is hydrogen, actually it will go back to aldehyde. The arrow pushing mechanism, first step is the base, the hydroxide, depronate the proton on this hydroxyl group. And then electron go back to oxygen to form the oxide. So this is first the deprotonation. You may notice this intermediate is the same as the last slide. So this intermediate now will have a different reaction. So because you don't have proton here, so this oxide actually will use electron, the lone pair, push back to form the double bond again, and kick off this cyanide as a leaving group. So this go back to the ketone or aldehyde if you have hydrogen again. The second step is called elimination. And so this is the decomposition of the cyanohydrin under the basic condition. Okay, next we will the hydrolysis of cyanohydrin under acidic condition will be shown here. So if you have the cyanohydrin treated with the acid in water, heat it up, you can actually convert this cyano group to carboxyl group, and this is called hydrolysis. And the arrow pushing mechanism, first step is actually protonation of this cyano group. The lone pair on the nitrogen take the protonation, and form this protonated intermediate. Okay, and then because of this nitrogen is now is a positive charge, this carbon is more electrophilic. So basically the first step, protonation, is activating this cyano group. And then the water act as a nucleophile, will attack this electrophilic carbon here. And then break the pi bond between the carbon and nitrogen. And this is another nucleophilic addition. And then product, I should say intermediate, is shown here. This intermediate will do a proton transfer. Basically, the proton on this oxygen transfer to the nitrogen. But when you draw arrow pushing, will be the lone pair of the nitrogen take this proton here, attack this proton, and push the electron here back to oxygen. So that's why this oxygen will be neutralized, and then the nitrogen will take the positive charge. And that's proton transfer. Sometimes you can just simplify it as PT, proton transfer. And then that is the intermediate. Again, it's a positive charged intermediate. And if you actually draw the resonance, actually this is more like the amide, but I will not draw that. So I just keep doing another nucleophilic addition of water. This oxygen's lone pair will attack this carbon. Again, this carbon is electrophilic, and break the pi bond between carbon and nitrogen to form the other intermediate. Now this is tetrahedral intermediate here, and you may notice that you can do another internal proton transfer. The nitrogen's lone pair take this proton and push the electron between oxygen and hydrogen back to the oxygen to form this intermediate. Now you can see this is ammonium, which is very good leaving group, and then one of the oxygen here from the hydroxyl group push back from the pi bond and kick off this leaving group, and then this is also called elimination, and then you have this protonated acid here. So last step, you just need a deprotonate proton here. Water now act as the base, deprotonate proton, push the electron back to the oxygen, then final product is the acid. This is a special acid because you have alpha hydroxyl group here, so it's called alpha hydroxyl carboxylic acid. Okay, so this is the arrow pushing mechanism of the hydrolysis of cyanohydrin. It's pretty long, and if you have any questions, just let me know. Okay, good luck.